Hello बच्चों, let's read the given question. The question says a stationary horizontal disk is free to rotate about its axis when a torque is applied on it. Its kinetic energy as a function of theta, where theta is angle by which it has rotated, is given as k theta square. If its moment of inertia is I, then angular acceleration of the disk is option A k by 2I into theta, option B k by I into theta, option C k by 4I into theta, option D 2k by I into theta. So, इस question में we need to understand about the concept of rotational kinetic energy. So let's suppose we have a body, let's say disk है हम मान लेते हैं, and it is rotating with angular velocity omega. So जो rotational kinetic energy का expression we can write, it is half I omega square. It is analogous to what we write for a linear motion, that is half mv square. So m का analogous I होता है for rotational, and v, that is linear velocity का is analogous is angular velocity in rotation case. ठीक है. Apart from this, we need to also understand कि alpha, that is the angular acceleration, is nothing but it is defined as the rate of change of angular velocity, and also omega, that is the angular velocity, is nothing but the rate of change of angular displacement. ठीक है. So these are the basic few point regarding rotation we need to keep in mind. तो अब यहाँ पे जो क्वेश्चन में हमें गिवन है वो गिवन है कि काइनेटिक एनर्जी एज अ फंक्शन ऑफ थीटा इज गिवन. सो काइनेटिक एनर्जी is given as k theta square, and kinetic energy we know it is half I omega square is equals to k theta square. So यहाँ से ओमेगा की जो वैल्यू आएगी that can be written as अंडर रूट ऑफ 2k अपॉन I इंटू थीटा स्क्वायर का थीटा हो जाएगा बाहर. नाउ वी आर इंटरेस्टेड इन कैलकुलेटिंग द वैल्यू of angular acceleration. So for that we need to differentiate this expression with respect to time on both sides since theta is variable. So यहाँ पे हम देख सकते हैं d omega by dt, and that will be nothing but alpha, and that will be equals to under root 2k by it is a constant, ये हो जाएगा d theta by dt. ठीक है. So now we can say this can be written as under root of 2k upon I into omega. ठीक है. Now from this we can say, if let's say this was our expression number 1, so हम क्या लिख पाएंगे from 1, alpha will be equals to under root of 2k upon I into omega from 1 2k by I into theta. So this result comes out to be 2k upon I into theta. So this is the expression for alpha we are getting for this question, जो कि मैच होता हुआ दिख रहा है हमें ऑप्शन डी के साथ. I hope you understood the solution. All the best.